In Math Lesson 111, we're working on volume explorations. Every day you will need your whiteboard marker and eraser, and your math journal. I would like you to go ahead and number 1 to 3. All right, so it's asking, is the value of the expression greater than 27 times 10? Well, I know that 27 times 10 is just 27 times 1, which is 27 with a 0 behind it. Now I'm going to see if it's greater than 270. I'll write a Y if yes, the expression is going to be greater than 270, or an N for no, it is not. Let me show you number 1. So I know I'm taking already 27 times 10. Without having to solve it, if I'm subtracting 50 from 270, there's no way it can end up being more than. So without solving it, if I'm subtracting from it, it's going to automatically be less. Pause your video, complete number 2 and 3. Remember to pause your video. We're building on all of this throughout the year, so you don't want to just watch it because you will not remember it and it won't stick in your mind as well. Here's my 27 times 10. I'm adding to it, so it's going to be greater than. 27 times 10, there it is, but guess what I'm doing? I'm multiplying by it. So yes, it would end up being more than 270. All right, do the same thing again. Number 1, 2, and 3 on your whiteboard. Is the value of the expression less than 498 plus 672? So less than that. Guess what? I don't even need to solve for 498 plus 672. I'm just going to find that expression and see what they did to it. If it makes it less than, you're going to say yes, that is less than 498 plus 672. Or no, if it's going to be more than that. So for example, number 1, they're subtracting from that, so yes, it would be less than. Go ahead and solve for numbers 2 and 3. Pause the video as needed. Well, in number 2, they're subtracting from it, so yes, it would be less than if they're already taking away. This one, they're dividing by 2, so yes, if you're dividing it, you're making that number smaller. Go ahead and erase your whiteboard. I want to have you imagine that you have a suitcase that's 14 inches long. So just imagine this is 14 inches. It's more than that, but I just pulled a suitcase out of the basement. It's 8 inches wide. So from here to here is 8 inches. And it's 20 inches tall. So it's 20 inches tall. So it's asking me to find the volume of the suitcase. So the volume, remember, is length times width times height. How much could I put inside of there? It gives me volume. So on a calculator, I want you to take 14 times 8 times 20. And remember, we're talking inches. I want you to write the volume of it using your calculator. Write that on your whiteboard. Pause the video. All right, if I, on my calculator, take 14 times 8 times 20, I get a volume of 2,240, watch this, cubic, remember volume is cubic inches. Whoops, let me back that up. Sorry, I need to put that here. 2,240 cubic inches. Now, if I lay the suitcase on its side, does it still have the same volume? I have that suitcase on the side now. Can I still hold the same amount of clothing or whatever inside? Does it have the same volume? Yes, absolutely it does. The length, if I look at the length of it now, The length of it is 20 inches. The width from front to back is 8 inches. And the height of it is 14 inches. So let's take the length, which is length. Remember, volume is length times width times height. The length is 20. The width is 8. The height is 14. Can you now take your calculator and let's take 20 times 8 times 14. Do you get the same volume? The answer is still 2,240 cubic inches. What that tells me is it doesn't matter which order you multiply, you're still going to get the same result. Now imagine I had an irregular shape. We're still on our whiteboards. Now this guitar, if I wanted to know how much it held, it would be really hard with those curves to be able to figure it out. So sometimes we just have to create like a box around it. So what I'm going to do is figure out the volume, or what is close to the volume, given the rectangular shape of the base of it and then the neck of it. I'm going to divide this into two rectangular prisms. This part, which should be this, and then this part, which should be this. I'm going to figure out the volume of each one of those. Again, using length times width times height. So let me take this one first. Number 1, let me make that red. On your whiteboard, I want you to write number 1. I want you to write length times width times height. So the length 20 times the width 5 times the height 15. Would you please on your calculator take 20 times 5 times 15. 20 times 5 times 15. What do you get? You should get 1,500. Now on your whiteboard, I want you to write number 2. We're going to find the volume of number 2. The length is 21. Write 21 times the width, which is 5, times the height, which is 5. On your calculator, figure out length times width times height. 21 times 5 times 5 equals, what did you get? You should have 525. And these, remember, are inches cubed or cubic inches. Now, if I add those two together, go ahead and add those two on your whiteboard. The volume of that guitar case is 2,025 inches cube or cubic inches. I would like you to try some with me in your journal on page 32. So open to journal page 32. Up at the top, again, pause the video when needed. We are estimating volumes of instrument cases. Use the mathematical models to estimate the volume of the instrument cases. Length times width times height. So here we have a trombone case. I would like you to use your pencil. I would like you to divide this into two separate rectangles. Go ahead and do that. Underneath or even in the middle, we're going to number this number 1 and number 2. So right next to here, I want you to write number 1, and we're going to find the length times the width times the height. So the length is 8 times the width, which is 4, times the height, which is 31 tall. And again, I just want you to use your calculator. So take 8 times 4 times 31 and tell me what you get. This should be 992 cubic inches. Then let's figure out the area of number 2, right? Number 2 between the trombone case and the drawing of it. Number 2. The length is 9, so write 9 times the width, which is 10, times the height, which is 4. So on your calculator, take 9 times 10 times 4, and what do you get? You should get 360 inches cubed. Now add those two together, so you can add the 992 cubic inches and the 360. And again, I'm fine with you doing that on your calculator. What is the volume of the trombone case approximately? 1,352. Make sure you're doing these calculations with me. Number 2. Let's do the French horn case. Take your pencil and draw a box around, that really isn't a box, is it? A rectangle around this shape and a rectangle around this shape. We'll call this number 1. We'll call this number 2. So go ahead and number those. And I'm going to put, you just have to find space somewhere on your math page for this. So let's start with number 1. I'm going to just erase this just for a minute. I think it's hard to see. So looking at just number 1 here, the length is 6. The width is this right here. And remember, opposite sides are the same length, so these would all be the same. That's where I'm getting the 14 from. And then the height is 14 as well. So on your calculator, take 6 times 14 times 14. What'd you get for volume? You should get 1,176. Now number 2, let me erase. Number 2, I'm going to put that over here. The length is 15, so take 15 times the width of 4 times the height of 16. On your calculator, take 15 times 4 times 16. And what do you get? You should get 916 cubic inches. And we're going to add together 960, which should already be in your calculator. So just add 1,176 to that. And we get a volume of 2,136 inches cubed. Down in number 3, it says use a mathematical model to estimate the volume of the instrument case. The only thing different with the xylophone case, it does narrow and it goes into 3 sections. So let's make a rectangle around each one of those sections. 1, 2, and 3. So somewhere on you could do it on your whiteboard if you wanted to, or somewhere in the white space in your math journal. I'm going to start with section 1. Section 1, so let's go ahead and figure out the volume of number 1. The length. Opposite sides are parallel and the same length, so 15 times the width, which is 24, and the height, which is 5. On your calculator, take 15 times 24 times 5 equals 1,800 inches cubed. Now let's take 2. Let me erase 1. We found the volume of that. 2. The length is 15. The width is 18. And the height, remember the height is the same in all of these. That doesn't change, so we multiply that by 5. So on your calculator, take the length of 15 times the width of 18 times the height of 5. It's the height consistently along the whole case. Would be 1,350 inches cubed. Let's erase that. And then the last one, the length, number 3. The length is 12. The width is 15. And of course the height is the same all along here, which is 5. So on your calculator, take the length, 12, times the width, 15, times the height of 5. You should get 900 inches cubed. And now we add together all 3 numbers. So 1,800 plus 1,350 plus 900 gives me a volume of 4,050 inches cubed. All right, that is it for the video lesson for today.